Hi, this is Mark from Omni Embedded, and this is Chapter A of the Jumpstart Training Series. We're going to talk about installation of the Vtrek product. The topics are going to be the Vtrek library installation, ProDev tool installation, the DDC tool installation, which is diagnostics and debug, and then we're going to create and test a starter build. In preparation, this series is using the NXP Kinetis K64 Freedom board throughout the Jumpstart training. You're going to need Kinetis Design Studio, so you can download that. It's a free tool. It's essentially an Eclipse-based tool. You'll also need to buy a Freedom board, and then from the Omni Embedded download site, you'll need the latest VtrekInstallation package, K64 package, and the K-Series support file package. I'm going to begin installation of the Vtrek library. Start the MSI file. And while that's running, I'm going to talk about the ProDev tool. This tool learns your project by scanning the source code files. You can create new projects from starter projects that are provided. Select and configure Vtrek and your own components. Provides file templates and code snippets, and you can also add your own. The tool is meant to simplify and speed up the production line tasks of coding, such as creating projects, creating new files, and configuring components. The configuration window forms are auto-generated, so the tool learns new configuration items as you add them. There's no need to update the tool. Now that installation is complete, I'm going to install the ProDev tool. Now that that's running, I want to go through the DDC tool. DD stands for Diagnostics and Development, and so this tool has a powerful interface to the data center and data items. Data items are centralized variables that have one writer and many readers. It can also interact with mode service. Now, mode service is a service that supports things like power on self-test, normal operation, entering and exiting a diagnostics mode, etc. And then you can also read RTI statistics. RTI stands for real-time interface, and we'll see all of these demonstrated as we do our test build. What you should do now is continue installation of the rest of the modules. There's a DDC installer, the K64 package, and then the K-Series support package. Once you've finished installing these, resume the video. Now, if you're not familiar with the K64 Freedom board, I want to go over a few things. It's an Arduino footprint, which makes it possible to use it as an early development board. You can create boards to plug into that footprint that has your I/O circuitry, or you can purchase I/O boards that use the ICs that you plan to use. It also has an onboard debugger feature, so all you need is a USB mini cable. You don't have to have actual debugger in order to use the board. If you go to this location where Vtrek was installed, and we'll just go have a look at that real quick. There are some pretty helpful files in here. This is actually, I believe, the J-Link bin that you can drop in a debugger. There's instructions in this folder on how to do it, and I believe this is a P&E lib file that you could drop in if you prefer P&E. The PDF file shows you the steps to go through. There's also a UART port that's wired out to the debugger microcontroller, and it presents as a serial port on your PC, and the DDC tool uses this connection. But on an actual target, a product that you're developing, you can have TX and RX of any serial port brought out, pinned to a connector, and then purchase a 3.3 volt logic level UART to USB cable, and it'll give you the same capability. The next thing we're going to do is create a test build. Now, I've created a folder for this purpose. This is where code's going to go. And then over in the Vtrek library, there is a business logic template, a folder template. I'm going to paste into this area. Now, you can put this anywhere on your local drive. This becomes the area where, as you develop your own code that can be reused among various projects, you'll put that into the business source library, logic library, and that's where you'll archive that type of data rather than adding it to the Vtrek library itself. I'm going to create a folder for this particular project, and now we'll fire up ProDev to create the new project. I'm also going to create a folder for Eclipse Workspace. And the reason I like to do this and keep my Eclipse Workspace separate from the project folder is that it creates a metadata folder and a lot of files. And I don't like to have those mixed in with my source library or my source code folder. These directions are going to tell you that the tool needs a couple of paths. One is your project path. Now I copied and pasted, but there's also a folder select button on here. You can use that as well, whatever is most convenient. And it also needs to know where your business logic library is at. Now you can name it whatever you want. I typically name mine the same as the folder name. And since the NXP K64 is the only derivative or vendor that we've downloaded, that's all that's going to show up here. So we'll select that and create our project. Now that the project has been created, we can go have a look at the project folder and see what's in there. So we have our application, a number of helpful files, tools, testing folder, etc. Now I'm going to create a folder for the workspace that's the same name as the project itself and fire up Kinetis Design Studio. Now, if you've not used Eclipse or KDS before, creating a new workspace is just simply selecting the folder that you've created for it, and then you can arrange the desktop however you want. I'm sure anyone who's used this before has their own preference on how to set it up. We're going to add a preference file that comes with Vtrek. It's in the Vtrek Eclipse folder, or Vtrek Live Eclipse folder. If you have your own preference file, you can just include that instead. This Vtrek preference file has the settings that we use for Vtrek development. And there's also some personal settings under editors. We use a 3-character space indent. And I like to set up some other settings. These two are important, by the way. This helps ProDev and Eclipse work with each other. Now we'll import our actual project that we've created. And that's as simple as just selecting the folder where the code resides. And then including it. Now there's a manual step that we have to do at this point. I'm going to show you where it is and why it's needed. If you go into this area in the properties setup, on the toolchain tab, you'll notice the build command is make capital V. Normally it's make, but we have an interceptor executable that needs to be put in with your make file. So if you go to this area under Vtrek, you'll see the make V executable. So if you just copy and paste that into the area where your make file is at, on mine it's the F drive under this path. You'll see a make file there. You'll also see the make V that I've already pasted in there. The reason this is needed is that Eclipse has an issue with parallel builds. When you do a parallel build, it starts the pre-build and the main build at the same time in parallel. And so what happens is main build is already running before pre-build stops. And what this executable does is separates those two steps so that you don't get out of order. So now we can start our build. There's a debug and release configuration on all of the starter projects. While that's building, I'm going to go to our test-driven development tool at this path. Now, this is a Microsoft Community 2019 build, and this is going to serve as a test build as well. Now, this project has all of the test scripts that we use to release Vtrek, and so it's in your space, and you can also use it to develop and test new modules or new software components that you're going to add to either your product or project or your business logic library. While that's building, we'll have a look at the list of test scripts. These are all C++ files, and there's a template CPP and H file in this list that you can use to copy and paste and start new test scripts. So we'll start this test. And then it looks like our embedded build is finished, so we'll download it to the board, the K64 Freedom board, and give it a test. I've already set up the J-Link. I'm using the J-Link bin file on this setup, and so I've already set up a J-Link debug configuration. Now we've got a shot of the K64 Freedom board. There's a green LED in the lower left corner, and our expectation is that that'll flash at a 0.5 second rate. And it looks like our VTDD test ran fine, everything passed, so that's a good sign. That means that we've got a good project set up. I'm going to pull up the DDC development tool. It needs to be set in this case for USB to RS-232 cable, and the starter project is already set up properly to run this tool through the USB cable. Now I'm going to create a control panel for the green LED, and we can just drag and drop that data item or shared variable over to it. I'm also going to set up a chart. And again, we can drag and drop and then set the color. You can put multiple signals on a single chart. So now I'm going to hijack the LED by checking this box, and you'll notice that the LED turned off. And now I've got control of that output through this tool, and you can see in the chart what's happening. If I release it, control goes back to the code that's running in the microcontroller. So it looks like we have a good build. We've got a project that's working the way it should. And that puts us to the end of this installation chapter. Let's see what's next. We've finished installation, and so chapter B is terminology and blocks. And then chapter C is a shorter one, it's code set navigation. So we'll see you there.